So the SOLs that address systems of equations only talk about nonlinear systems. They don't talk about the kind we did in the homework last night. They talk about what we're doing today. In our textbook, there's only one page on that. There's not a whole section on it, and it's actually buried in chapter 10, which we don't even do. So that is where this is coming from. And the first few slides I'm going to do are the same slides we had yesterday. Right, so by system of equations, we mean more than one equation, more than one variable. If it's solvable, it's because there's the same number of equations as there are variables, right? Now, in this class, we only deal with 2x2s. 2 equations, 2 variables, like all the ones we did last night. Okay, so a nonlinear system is when at least one of the other equations is not linear. And it could be linear quadratic, meaning one's a straight line and one is not. It could be quadratic quadratic, which means neither one is a straight line. And we already looked at this last class, but we know that the solution to a system are the intersection points, the set of all the intersection points. If it's 2 straight lines, you know, it could have one, it could have none. It could all be the same line, which means infinitely many solutions. If it's linear quadratic, straight line, then, you know, if it's linear quadratic, the most number of solutions you're going to get is 2. It could be 1, there could be 1, and there could be 0, or there could be 2. And you could do the same thing with all these shapes. I think we showed that last time. And if it's quadratic, meaning if you had more than one of these shapes on the same background, it could be up to 4 solutions. Right? You could conceive of like move this circle here, and they would cross in 4 places. Or move this ellipse here, 4 solutions. I'm not going to go through that slide again. So we already did the solve by substitution and elimination. First, we're going to go back and we're going to do the solving a linear system by graphing. And then we're going to do the substitution elimination for nonlinear system and a graphing for a nonlinear system. So this is where you need to have your calculator and be playing along. Okay? If you're not trying, there's nothing I can do for you. So step 1 in solving a system by graphing is you've got to be able to put them in the calculator. Right? The calculator has a y equals button. So unless they're solved for y, you can't put them in. So you need to solve for y. Solve both equations for y. In this problem, these two here, right, that'll be 4y equals negative 3x plus 12, divide by 4, y equals negative 3/4 x plus 3. Okay, solve for y. That's not supposed to be the tricky part. Do you remember when at the very beginning of this class, when we did kind of a review of solving equations and we got to what were called literal equations, meaning more than one variable? I mean, that's why you got to be able to solve equations with more than one variable, like this. I mean, we can't stop and say, oh my gosh, what do I do? You know, you solve it the same way you would if there was just one variable. All the same properties come into play. Okay, so if those are my 2 equations, then you're going to enter them in the calculator under the y equals button. So you hit the y equals, and on line 1 you put negative 3/4 x plus 3. On line 2 you put negative 2x plus 10. Again, if you want to use the fraction format like that, do you remember where you look for that? Alpha, y equals 1, right? But you don't have to. I mean, you could put negative 3/4 x like this, right? You could say parentheses, negative 3 divided by 4, parentheses x. I mean, that's fine. That's not what I would do. I mean, I would probably go like this. I would probably go negative 3x divided by 4. Okay, that's also negative 3/4 x. But if you want to use the fraction format, it'll look like that. Alpha, y equals 1. So when you've got those in, let me know. Thumbs up. Good. Anybody still need help with that? Okay. Don't be shy. Okay, once you've got those in, okay, if you look at the graph, just say graph. And if you don't get a picture that looks exactly like that, then do zoom 6. Zoom 6 will bring it back to the middle of the graph. And it should look just like that. I mean, how many solutions do you see on that? There's one right there. That's it, right? That's it. Okay, you don't have in. You're using minus sign instead of a negative sign, and that's not negative 3/4 x plus 3. No, it's not. I just showed you the one first term. I didn't put the whole thing in there. You got to use a negative, not a minus, in front of the. Okay, so there's one solution. That's what we're going to look for. And actually, you don't have to take the step and graph. I just wanted you to see. And we can understand there's usually like 2 problems on the SOL which deal with systems. And one of them is a graph like that, and it just says estimate the solution by looking at the graph, or say how many solutions you see, something like that. Then there'll be another one where you actually solve. Okay, here's the next step. You do second trace 5, right? Second trace, and you should see this menu right here, and the number 5 is intersect. We're looking for the intersection. Right. When you do that, you should see this screen exactly, and it's going to say on the bottom left, first curve, and in the top left, it's going to have one of the equations that you put. The first one is there. So you always say yes. Are you happy with that? Yes. Hit enter. So second trace 5, enter. Now it's going to ask you for the second curve, and you should see that the cursor has jumped to the other graph, and that's the equation in the top left. Is that what you see? Okay. Then you hit enter again, and now it's going to say guess. It's asking you the question. Do you want to guess? I don't know why it uses that terminology, but it does. And you always say yes. Enter. And it should look like that screen right there. And it's going to, the intersection point is 5.6, negative 1.2. The cursor is blinking right on the intersection point. Did it work? Okay. And anybody else? Morgan? Ashley? Good. So these are the steps, just consolidating them into one place. First, you solve both equations for y. Then you enter them under the y equals on the calculator. Then you do second trace 5. Enter, enter, enter. What's that? Yeah, well, you mean you need this graphing calculator to do it. That's okay. Well, I don't know if Casio's will have totally different steps if they do this. Yeah. That sounds weird. You know, if you know a little bit about these calculators and you think that sometimes you could just like hit the trace button and then like move the cursor to get close, that's not going to be exact enough. You have to go through these steps to get it exact. There's always somebody that will do that part. You know, it'll be so close, but it's really not there. Are we good? Okay. So go ahead and try to do that with those two equations. They're already solved for y, so all you have to do is put them in the calculator and go through those 5 steps. Yeah, I mean, you could do that just to have something I can sign off on. Just write the 2 equations and write the answer. Who's got an answer? Okay. Shane, what'd you get? 2 negative 3. Did everybody get 2 negative 3? Okay. Correct. That's right. Isn't that easy? Don't worry, it'll get worse. But here's the thing to understand about this, right? Let's say you were trying to solve one of our equations from the test, right? We only had 2 equations and they were right there. Let me go back here. Boom. What you can do to solve some of this, and it's a little more complicated, but it actually pretty much works exactly the same way, is you put on line 1, y1 equals 3 over x plus 1, and you put on line 2, y2, 1 over x squared minus 1. And then you go through the steps, right? So you go second, trace, 5, enter, enter, enter. There's your answer. Okay? So, I mean, that can help you to solve any of the kind of equations. I mean, so far we've done linear, absolute value, quadratic, polynomials, radicals. We really didn't do logarithms and that, but we could. Rational. I mean, and they're all going to work the same. With the calculator, they all work the same way if you know how to do this process. Okay. Okay. So go ahead and do in the book 30 and 31 on page 139. They were supposed to have been in our homework last night, but because we did, yeah, just put them on the U tries, right? See if I, yeah. Why?
Like the binding on it, like the glue is coming off, and like there's a rip right here. I don't know how.
Okay, just a second. Right, that's at 30. Tell me when you got an answer on the first one.
Rather than treating it any different, I was like falling apart and just like ripping here.
Well, some force was put. That doesn't just fall apart. Doesn't just disintegrate. It's probably the way you throw around your backpack. So you put that stress on there. I mean, you got to be a little more careful with it than that.
Should I put like tape on it?
Yeah, I mean, you could do that. I mean, you got to be more careful because that. I mean, it's not that the book was made bad. You've just been kind of throwing it around a little bit.
Well, I was just asking her, should I put tape on it?
Sure. Sure. Who's got an answer for the first one? Rebecca. Rebecca's first. 4, 2.5. Does that sound right? 5 over 2, 2.5, same thing. Okay. So if you entered the fraction as a fraction, then it says 4 5 halves. If you didn't enter it as a fraction, then it's 4 2.5. But it's the same thing. Okay, now these two, you're going to have to solve for y first. Right? Before you can enter it in the calculator, you got to solve for y. That's fine. Right? So these are the two equations you have to put in. Second trace 5. Second trace 5. I don't know what you're doing. Second trace 5. Enter, enter, enter. Here. How many? Who got an answer? What'd you get? What does it say? Error. Why is there an error? Hit the graph. Look, go back to the graph. They're parallel lines. They don't cross. That's what happens if you do this, and they actually don't intersect. So, and how do you knew that was going to happen because look at these two lines. They have the same slope, -1/2, and different y-intercepts. So they were never going to cross. Okay? So, proceed. So now we're going to use substitution and elimination with a nonlinear system. Right? So here were the steps for substitution. And here's the system that we're going to work on. It says solve one equation for one variable. You choose. So which one of these do you think you'd want to solve? The first one for x. Okay, so let's say I solve it for x, and then what's the next step? Then I substitute for that variable in the other equation, right? But notice in the other equation, it's x squared. So you really don't need to solve this one for x. It's okay to solve for x squared, because that's what you're going to plug into the other equation, right? I mean, in this problem. So if I do this, if I say add y squared to the other side, x squared equals y squared plus 9. Then that you don't need to take the square root of that, because in the end you're plugging in for x squared. So that can happen with a nonlinear system. Okay, then the second step says substitute for that variable in the other equation. So in this equation, in place of the x squared, put y squared plus 9. And then solve for y squared first. Okay, so what should I do first? Combine like terms, right? There's y squared plus 9y squared, which is 10y squared plus 9. Subtract 9. 10y squared is 160. Divide by 10. Y squared equals 16. And then finally, you still got to solve for y, because we're looking for points on the graph. You got to take square root of both sides. Okay, what do you get when you take the square root of both sides? Plus or minus 4. Remember, when you take the square root, always plus or minus. Okay, that's this step right here. Okay, then you're supposed to substitute that answer into the result from step 1. Well, the result from step 1 was here. And actually, we don't need y. We need y squared. Right? So we could use this line right here. Y squared equals 16. You're going to put that right there. X squared equals 16 plus 9. X squared equals 25. So x equals plus or minus 5. Okay, so our x coordinates are 5 and negative 5. Our y coordinates are 4 and negative 4. You're going to have to, for this problem, you're just going to have to take all possible combinations of the x's and y's. Right, so that'll be 5, 4. That'll be 5, negative 4. It'll be negative 5, positive 4. And it'll be negative 5, negative 4. So there's 4 possibilities. Like we said, when you have 2 quadratics, then you can get up to 4 solutions. I mean, I can tell you that this one is a hyperbola. This one is an ellipse. You know, hyperbola looks like this. An ellipse looks like this. So you can see how they could intersect in 4 spots. Okay, so try to do the same thing with that. Solve one of those equations for the squared variable, and then substitute to the other equation. See whether you could get it. At least the first variable. Anybody get the x squared? What'd you get, Parker? X equals 3 and y equals 4. Anybody want to correct them a little bit on that?
Well, x squared equals 9.
So what does x equal? No, plus or minus. It's got to be plus or minus. When it's right to say that x squared equals 9. When you take the square root, you've got to include the plus or minus. Okay. So which one did you solve for which variable? The bottom one for? We're doing substitution right now. Who solved one of these for y for a variable? John? Here? Okay. So then this one would be x squared equals 25 minus y squared. Okay. And then we're going to plug in to the other equation for that. 2 times 25 minus y squared minus y squared equals 2. Right? That's 50 minus 2y squared minus y squared equals 2. Does that look right? Yeah. Yeah, it does. Okay. So this is negative 3y squared equals negative 48. So y squared equals 16. Y equals plus or minus 4. Okay, so now that we know the y, we got to find the x. So where do we plug in the x? Right there. That's the result of step 1. So x squared equals 25 minus 16, which is 9. So x equals plus or minus 3. And then you're going to have to do the same thing we did with the other one, right? You have to take all the combinations of plus or minus 3 and plus or minus 4. 3, 4. 3, negative 4. Negative 3, 4. Negative 3, negative 4. In this case, it was an ellipse and a circle. But again, ellipse, no, sorry, hyperbola and a circle. Okay. Okay, elimination. Remember with elimination, you're trying to line up the variables so that one of them have opposite coefficients and they just cancel. So in this problem, it's not there yet, but what could you multiply times one or the others to make it so? Yeah, I mean, if you do the top one by negative 1, then that's probably the easiest thing to do. What else could you do? You could multiply the first one by 9, and then these would cancel. So it doesn't matter. You could be right by doing either one. So let's do negative 1. So, and I'll put the result right underneath. So that's negative x squared plus y squared equals negative 9. So that was our step 1. Multiply one or both equations so that we've got opposite coefficients. Right. Now, just consider these two. If we add them up, will it cancel the x's? Sure. So you add them up. 10y squared equals 160. This is the same system we did with substitution. Does that look familiar? So we've gotten to the same spot. So I'm not going to continue it after here, but that's how you would use elimination for a nonlinear system. You know, just same process. We're actually going to cancel the squares this time. Now, you go ahead and try it. This is the same one you did before. And I think what Parker did when he did it, he did elimination on it because it obviously this one was set up to do elimination. You're showing off. So at least get to the point where it looks like what we did last time. Actually, the way I did it up here, probably it's not going to look like it did last time. All right, so I mean, it'll work out the same. It's the same system. The math should look pretty similar because it's the same problem. Okay, so that's substitution and elimination with a nonlinear system. Now we got to do graphing. So when you solve by graphing, remember the first step of solving by graphing. You got to put it at the y equals. So you're going to have to solve for y. And the second equation here, well, that is solved for y. But the first one, you're going to have to do something to solve, right? You're going to have to solve it by doing this. Y squared equals 36 minus x squared. And it's not going to be enough to leave it as y squared. You're going to have to take the square root of both sides, right? And then, so what is that going to look like? Plus or minus the square root of 36 minus x squared, right? You're going to have a plus and minus. So that's the first step. Solve them both for y. We did that. Second step, put it at y equals. Okay, well, I'm going to put this one first. Y equals x minus 2 squared minus 3. Okay. Now, in order to enter the plus or minus, you're going to have to do the plus on line 2 and the minus on line 3. If you want to get the whole shape, you're going to have to put them individually. So on the first line, I'll put the square root of 36 minus x squared. And get out of that. And then go to the next line and put negative the square root of 36 minus x squared. Right, plus and minus. I could tell you the first one is a circle, has a radius of 6. The second one is a parabola. It's been shifted 2 to the right and 3 down. If I look at the graph, zoom 6. There's the parabola, right? This, well, that doesn't look like a circle, does it? But you see the grid marks are not evenly spaced. They're different on the y-axis than the x-axis, yeah. Did you put both of these here? You got to have the plus and the minus, right? So the top half of it is the plus, the bottom half of it is the minus. So how many solutions to this system do you see? two. There's one here and there's one here. Okay, so go through your steps. Right, the steps are, no, we've already done that. Second, trace 5. Second, trace 5. Now notice when you do that, where is the cursor blinking? It's right there. It's definitely on the parabola, which was the first equation. Okay. Now, when I hit enter, it jumps to the top half of the circle, which is good because that is the part of the circle which is intersecting, and it's blinking there. So we hit enter, and now we say guess, and the cursor jumps to the nearest intersection point. So there's one solution, negative 0.986, positive 5.92. Okay, but we're not done. We got to find the other solution. We know this one. Now we got to find this one. If I just go through the same steps, it's going to keep finding the same point. So this is what you have to do to make it find the other point. You're going to go second, trace, come on, second, trace 5, okay, and move the cursor so that it gets closer to the other point. Okay, this close, and then enter, and it jumps to the top of the circle, and then you say guess, and it goes to the other point. So you need to find 2 points. Just get the cursor a little closer to it before you hit guess. All right, and then there's your intersection point. Now, what if this thing actually intersected with the bottom of the circle? Then it would go like this. It didn't, right? So, but I'm going to show you just to show you. Second, trace 5 for intersect. Okay, first it's on the parabola. Okay, now it jumps to the positive square root. If I wanted to go to the negative square root, hit the down arrow. And now it jumped down to the bottom. Now, if there was an intersection point, it would find the intersection point. There is not an intersection point. So what's going to happen if I hit enter? Right, guess. Error, right? Because it didn't intersect. It says no sign change, but there's no, it didn't intersect. But if you have to jump down to the other part, just use the down arrow. It'll go down. So the answer, I'm not going to write the answers there. They were up here. So I think the hard part can be solving. You got to solve, take a square root, remember the plus and minus, enter it on 2 lines, and then go through this process twice. You know, if you have to, move the cursor over. Okay, try to do that one right there. This is a nonlinear system. Is it linear quadratic or quadratic quadratic? Is it linear quadratic or quadratic quadratic? It's linear quadratic. The first thing is clearly linear. So what's the most number of solutions you could find? 2. So go ahead and put it in the, solve the first one for y. And then put them in the calculator. Right, so you get a graph looks like that. How many solutions? 2. There's one there and there's one there. Did you find them yet? Who's got the first? Who's got this one right here? Curtis.
Negative 0.372 and 4. I'm sorry. Yeah.
Negative 0.372.
And 3.6.
Looks right. What about this one? Who's got the second one? Parker. 3.6? That one? That doesn't look right. Sandy, what you got? 5.37 for X? 9 point, that looks about right. Let's try it. Second trace 5. Okay, I'm going to cursor over so that it's closer to that second point. Okay, enter, enter, enter. 5.37, 9.37. Good? Okay. So in the homework, there's only 3 problems, right? The first one is graphing. So you might want to take it out, do it right now, and then you can save these other 2.